Artificial intelligence explained to rookies what AI really is. Artificial intelligence, or AI, is the technology that enables machines to learn from experience and perform tasks that, up until now, were thought to be only executable by humans. Far from science fiction and Hollywood studios, AI has really entered our daily lives, affecting everything from education and the economy to technology, manufacturing, and healthcare. But experts say that that's just the beginning. Find out what this AI thingy really means. Welcome back, folks, to another edition of Sweetie Kiwi. How you doing today? I hope you are doing fantastic. I'm doing marvelous, if you were to ask me. And if you are doing as great as I am, go grab a cup of coffee or tea or vodka and let's roll. Today, I want to talk to you about AI, artificial intelligence, and I want to break it down for you. I want to explain it to you in simple terms. How is artificial intelligence applied? Now, before I get into the nitty-gritty, just want to quickly recap and tell you that artificial intelligence, when you hear that word, is simply the technology that enables machines to learn from experience and perform tasks that, up until now, were thought to be only executable by humans, right? So how is artificial intelligence applied? So popular misconceptions tend to place AI on an island with robots and self-driving cars, right? We've seen this in movies. However, this approach fails to acknowledge artificial intelligence major practical application, processing the vast amounts of data generated daily. So if experts are able to get to the point where companies, individuals, and computers can strategically process certain data in real time, we can get huge insights. We can automate tasks, and those things, insight gathering, task automation, they can occur at a fast rate and scale. So parsing through the mountains of data created by humans, AI systems perform intelligent searches, interpreting both text and images to discover patterns in complex data and then act on those learnings. Let me talk to you about the basic components of artificial intelligence. What are the cornerstones? What are the pillars, if you will? Many of AI's revolutionary technology are common buzzwords like natural language processing, NLP, deep learning, and predictive analytics. State-of-the-art technologies that enable computer systems to understand the meaning of human language, learn from experience, and make predictions are also part of the AI continuum, not conundrum. Understanding AI jargon is the key to facilitating discussions about the real-world applications of this technology. Now, don't get me wrong, the technology are clearly disruptive. They revolutionize the way we humans interact with data and make decisions, and they should be understood in basic terms by all of us. Now, we have on the screen right now, we're putting on the screen right now, a nice illustration by a company called Enoplexis. And we just love it because it kind of recaps what artificial intelligence really is. So you have the 6 elements, the hexagon, the 6 elements that really comprise, that really underpin artificial intelligence as it is today. So you have neural network, deep learning, natural language processing, cognitive computing, computer vision, and machine learning. Don't worry, this might sound like jargon for you right now, but I will explain. I'll go through each of them in this show. Let's talk about machine learning, which means, in other words, learning from experience. Machine learning, or ML, is an application of AI that provides computer systems with the ability to automatically learn and improve from experience without being explicitly programmed. In other words, you are empowering the machine. You are rendering the machine autonomous in the learning and application process. So machine learning focuses on the development of algorithms that can analyze data and make predictions. So beyond being used to predict what Netflix movies you might like, or say the best route for your Uber, machine learning is being applied in various critical sectors. I'm talking about life sciences, pharma, healthcare, And all this, the applications here are helping to treat diseases, to diagnose diseases, are helping to interpret medical imagery and accelerate drug development. All right, I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Q. We are still having a conversation today around artificial intelligence, and I'm explaining to you in a very simple language. Let's talk now about deep learning. Deep learning means that the machine are self-educating. Deep learning is just a subset of machine learning that employs artificial neural networks that learn by processing data. Artificial neural networks mimic the biological neural networks in the human brain. So you have multiple layers of artificial neural networks working together to determine a single output from many inputs. And by doing that, they can find out the image of a face, for example, from a mosaic of tiles. So the machines fundamentally learn through positive and negative reinforcement of the task they carry out, which requires constant processing and reinforcement to progress. Let me just give you an example. Another form of deep learning is speech recognition, which enables, for example, the voice assistant in phones to understand questions like, "Hey Siri, hey Alexa, how does artificial intelligence work?" Right? What about neural network? Neural network, when you talk about neural network, you're in essence talking about making associations. Neural networks enable deep learning, that we know. Neural networks are computer systems modeled after neural connections in the human brain. The artificial equivalent of a human neuron is called a perceptron. Perceptron, Perceptron. So just like bundles of neurons create neural networks in the brain, stacks of perceptrons create artificial neural networks in computer systems. So neural networks learn by processing training examples. The best examples come in the form of large data set, like say a set of 1 million dog photos. So by processing the many images, in this case the inputs, the machine is able to produce a single output answering the question, is the image a dog or not? This process analyzes data many times to find associations and give meaning to previously undefined data. So through multiple learning models like positive reinforcement, the machine is taught it has successfully identified the object. Let's talk now about cognitive computing. When you talk about cognitive computing, you're talking about making inferences from context. So cognitive computing is another essential component of our artificial intelligence. It helps imitate and improve interactions between humans and machines. Cognitive computing seeks to recreate a human thought process in a computer model, in this case by understanding human language and the meaning of images. So together, cognitive computing on one end and artificial intelligence on the other, they strive to endow machines with human-like behaviors and information processing abilities. All right, I'll be right back right after this. Don't go anywhere. Welcome back, folks, to another edition of Sweetie Kiwi. I hope you are still having a wonderful time with us so far, and we are explaining to you the important element, the important topic of artificial intelligence. And I'm just explaining this to beginners in very simple language. And if you love this kind of content and you love the clarity and quality of the content so far, please consider subscribing to our channel and turn on the notification bell so you can be notified, you can be informed in real time whenever we drop a new show. And we do this every single day, rain or shine. And also, please comment below, ask us any questions. Our team reviews all questions, and if we can answer, if the question is pertinent, we will get you the answer. Like this content and share. I want to talk to you now about natural language processing, NLP. So you have to understand the language. NLP allows computers to interpret, recognize, and produce human language and speech. So the NLP ultimately seeks to enable seamless interactions with the machines we use every day, by teaching systems to understand human language and context and produce logical responses. Let me give you an example. So, real world examples of NLP, you have Skype Translator, which interprets the speech of multiple languages in real time to facilitate communication. Computer vision, another pillar of artificial intelligence, understanding images. Computer vision is a technique that implements deep learning and pattern identification to interpret the content of an image. I'm talking here about graphs, tables, and pictures within PDF documents, as well as other text and videos. Computer vision is an integral field of AI, enabling computers to identify, process, and interpret visual data. So applications of this technology are still nascent. They have begun, they are still nascent, but once they are fully deployed, they will revolutionize industries like research and development and healthcare. Computer vision has been used to diagnose patients faster by using computer vision and machine learning to evaluate patients' X-ray scans. Let's talk about some additional technologies that are supporting artificial intelligence nowadays. You have GPUs, right? Graphical processing units are a key enabler of AI because they provide the massive computing power necessary to process millions of data and calculations quickly. The Internet of Things, IoT, is another thing. The IoT is the cumulative network of devices that are connected to the internet. So the IoT is predicted to connect over, check this out, 100 billion devices in the coming years. 100 billion devices. Of course, we're not just talking about phones here. Obviously, we are only 7 or 8 billion people, and if everybody had, 10 phones, we'll still be around 80 billion. So the devices I'm talking about go from your coffee machine to your garage door to the temperature adjustment in your adjustment system in your house, and so on and so forth. Right? So that's the power of the Internet of Things. Intelligent data processing is being optimized as we speak, using advanced algorithms for faster multi-level analysis of data. This is the solution to predict rare events, comprehending systems and unique situations. So with the integration of application processing, with the integration of application processing interfaces, aspects of artificial intelligence can be plugged into existing software, augmenting its normal function with AI. So this is it, folks. Really hope that you had a good time, and this is just want to quickly recap what I spoke about today. I spoke about how is artificial intelligence applied, what are the basic components of artificial intelligence, machine learning, deep learning, neural network, cognitive computing, natural language processing NLP, computer vision, and additional technologies that are supporting artificial intelligence. Just know that the keywords in the next 3 to 4 years will be 5G, artificial intelligence, robotics, and the most important thing is IoT, because IoT will actually touch our daily lives more directly than, say, artificial intelligence, which is now a subset, a topic that interests more businesses and organizations and governments, including the military. But IoT is really where we as consumers will benefit massively in the next 5, 10, 15, 20 years. All right. I will see you next time. Until then, remember, stay marvelous.